Hi guys, okay, we have January 2020, paper 1, formula sheet, 22 questions, question 1A. Okay, nice start guys. We have coordinates A and B, and it says work out the midpoint. So the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. It's just because it's halfway between the two x coordinates and halfway between the two y coordinates. This is x1, y1, and this is x2, y2. Just make sure you get them correct. If you chose x1, y1 for this and x2, y2 for this, you would also get the same answer, so it's fine. 5 plus 13 over 2, comma, minus 4 plus 1 over 2, which gives me 5 plus 13 is 18 over 2 is 9, and minus 4 plus 1 is minus 3 over 2, which is minus 1.5, or minus 3 over 2. B, the line L has equation of this. Write down the gradient of the line. So write down means you don't even have to do any working. This is the gradient, guys. It's the coefficient of x, what comes before x. He's written it in not in mx plus c, but c plus mx if you like, but that's the gradient, and it's negative 3. So just make sure you write negative. Same line. It says, does the point with coordinates this lie on the line? You must give a reason for your answer. Okay, so we're going to sub, if it lies on the line, then if you sub in this for x and this for y, because that's what a coordinate is, x and y, it should satisfy this equation. So let's try it. And I'm going to write down what's happening. Sub in 100 minus 302. And I get minus 302 equals 2 minus 3 times 100, because x is 100, minus 302 equals 2 minus 300, minus 302 is equal to 2 minus 300, be very careful guys, is negative 298. So the answer is no, as well, you can write as negative 302 does not equal negative 298. You can write here not equal. If they were equal, that would mean the point is on the line. Okay, and that was only worth 1 mark, guys. So anyway, question 2. Lowest common multiple of 28 and 105. Okay, I need to get my prime factors. So guys, when they aren't asking you to find the prime factors and show you're working, you can just use this 28 fact. So 28 is 2 squared times 7. 28 equals 2 squared times 7. And 105 equals 3 times 5 times 7. 3 times 5 times 7. Now we are going to draw our Venn diagram. This is 28, and this is 105, and we're going to put these numbers in here. So what's common? 7, so I put a 7 in the middle. What's left in 28? Well, I have a 2 squared here. And what's left in 105? I have a 3 and a 5. So 3 and a 5. So the lowest common multiple, I just multiply all of these pink numbers. So it's 2 squared times 7 times 3 times 5, which is 2 squared times 7 times 3 times 5, 420. So this is 420. Okay, question 3. The diagram shows a shape. Okay, this is a shape. The shape has area 129 centimeters squared. Work out the value of x. Okay, definitely, guys. I mean, I'm just gonna cut this in. Well, I'm just gonna draw a line straight down here. Okay, so to find x, I need to use the fact that the area is 129. So the area of this shape is 12 times 9, which is 12 times 9, guys, is 108. And if this length is 9 and this length is 6, then this length is 3. So this guy's area is 3 times x, or 3x. So we know that 3x, the area of this rectangle, plus the area of this rectangle, has to equal 129, because he tells us it's equal to 129. Solve this. 3x equals 129 minus 108 is 1, 2, no, sorry, what am I doing? It's just 21. And then x is 21 divided by 3, which is 7. So this x is 7. Question 4. We have a frequency table, weights of 40 babies. Write down the modal class. The modal class is like the mode. Which is the mode? It's not, don't write 16, guys. 16 tells us that this is the mode, or this is the modal class. So it's 3 less than w less than or equal to 4, because this is the most common weight class or range for babies. Most babies, well, not most, but the highest number is in this 16. Okay, work out an estimate for the mean weight of babies. Okay, so guys, I like to, at the side here, do what I call midpoint. So the midpoint is the midpoint of this. So between 2 and 3, it's 2.5. 3 and 4 is 3.5. 4 and 5 is 4.5. 5 and 6 is 5.5, and then 6.5. So it's the middle of these two numbers. It's not always 0.5. It depends what these numbers are. Just add them together and divide by 2. Then we want to do the midpoint times the frequency. I'm just going to call it m times f. So I need to do 12 times 2.5. That would be 30. I need to do 16 times 3.5. That would be 56. Guys, obviously just use your calculator. I think that is 56, yes. 4.5 times 9 would be, that would be 36 plus 4.5 is 40.5. 5.5 times 2 is 11, and 6.5 times 1 is 6.5. Therefore, the mean is equal to, we're going to add up all of these and divide by the total number of babies, which is 40. There's 40 babies, it tells us. So the mean is going to be 30 plus 56 plus 40.5 plus 11 plus 6.5, and this is all divided by 40, and this gives us hopefully the correct answer. Hang on, let me do this. So it's 30 plus 56 plus 40.5 plus 11 plus 6.5 all over 40, and I get 18 over 5, which is 3.6, and that is correct. 3.6. I can write that here. Then it says one of the babies is going to be chosen at random. Find the probability that this baby has a weight of more than 5 kilograms. Right, let's go back to the table. Okay, how many of these babies have a weight of more than 5 kilograms? Well, look, it tells us these ones are between 5 and 6, and these ones are between 6 and 7, are greater than 5. So actually there are 3 babies in total, these 2 and this one, 3 babies that weigh more than 5. Therefore the probability is just 3 out of the total, which is 40. And that's it. Question 5. Okay, 120 children go on an activity holiday. The ratio of girls to boys is 3 to 5, right? Then I'll read the rest in a minute. So let's find out how many girls and boys there are. So the first thing we're going to do is we're going to go 3 plus 5 is 8. We add the ratios so we can split it into eighths. I do 120 divided by 8. Use your calculator, guys. It is, actually I need it myself, I think it is 15. And then I do 15 times 3 is 45, and 15 times 5 is 75. Therefore, we have girls is 45, so there's 45, let's write this here, 45 girls and 75 boys. Okay. He then says 16/25 of the boys go climbing. So boys climbing. Well, hang on. Let's look at the boys first. Boys, 16/25 go climbing. So there's 75 boys times 16 out of 25. Use your calculator. That's 3 times 16 is 48. So 48 boys go climbing, which means 75 minus 48, which is 27, go sailing. Okay, so this is climbing. 48 climbing, 27 sailing. Okay, girls. Twice as many girls go sailing as go climbing. Work out how many children go sailing on Sunday, right? So we just need to find out how many girls go sailing and add it to this. So it says twice as many girls go sailing as go climbing. So sailing to climbing, I can't write climbing, sailing to climbing is 2 to 1. So we now need to divide our 45 girls in the ratio 2 to 1. So I have to do this thing again, guys, where I do 2 plus 1 equals 3. And then I do 45 divided by 3, which is 15 again. And then I do 15 times 2 for sailing, which is 30, and 15 times 1, which is obviously 15 for climbing. So that means we have, this is sailing and this is climbing. The question says, how many children go sailing on Sunday? 27 and 30, which when I add together gives me 57. So I'm going to do 30 plus 27 equals 57. And I'll write that here. Okay, question 6. Write this as an ordinary number. Okay, so guys, what I like to do is this is going to be a small number because it's 10 to the minus 4. So I like to put in enough zeros to begin with. So let's just do 0, 0, 0, 0, 0. I'll go too many just to show you my point. Put in enough zeros and then 7, 8. Forget the decimal point for a second. Then we go to where the decimal point is, 7.8 here. And because it's negative 4, we're going to make it small. So we're going to go left. And we're going to go left 4 because that is 4. So I go to here, 7.8, and I go 1, 2, 3, 4, and I stop. How many zeros? So this is where I'm going to be. How many zeros? 1, 2, 3. So the answer is 0.00078. 3 zeros and then 7, 8. Okay, part B. Work out this, give your answer in standard form. These questions, guys, look really difficult, but they're not because we have a calculator. So I just have to put 5.6 times 10 to the 4. Without a calculator, it is difficult. 5.6 times 10 to the 4 plus 7 times 10 to the 3 over 2.8 times 10 to the minus 3. Press equals, and I get this 225, and I have 1, 2, 3, 4, 5 zeros. So this is equal to 2, 2, 5, 1, 2, 3, 4, 5 zeros. And it says give your answer in standard form. So the same thing, guys, except we're going to the right. So I go 2.25, which will be here. So I have to start there because it has to be the first numbers between 1 and 10, less than 10. So the first number is 2.25, and I'm always going to multiply by 10 to the power of something. What's the power going to be? Well, it's going to be 1, 2, 3, 4, 5, 6, 7. So it's 10 to the power of 7. Okay, that is question 6. Question 7. Expand. How do we expand two brackets? Well, we do this times this, plus this times this, minus this times this, minus this times this. M times m is m squared. M times 5 is plus 5m. Minus 8 times m is minus 8m. And minus 8 times 5 is minus 40, giving me m squared. Plus 5 minus 8 is minus 3m minus 40. You can put it there if you want. B, factorize fully. So I need to take out a common number, which is 5, and a common letter, which is y. Open bracket. If I've taken out 5y, what do I need to multiply by to get 5y? Well, it's 1. What do I need to multiply to get 20y squared? Well, 4 to get me the 20, and another y to get me the y squared. And that's it. That's, hopefully, guys, we can all do that. Question 7, nice easy question. Or sorry, that's only part A and B. All right, part C, this is actually really easy because anything to the power of 0 is 1. And we do need to know that. Anything to the power of 0 is 1. Then part D, fine, this isn't that easy a question. We have to solve this. So my first step is I don't like the denominator, this 2, so I'm going to multiply across by 2. So I do 2 times 3 is 6. So multiply this side by 2, and I get this. Multiply this side by 2, and I just get 9 minus x because this 2 cancels, which is why I did it. Then multiply this out. 6 times 2x is 12x. 6 times negative 5 is minus 30. Equals 9 minus x. X is to the left, 12x plus x, because it's minus there, so I'm going to add an x. And then 9 plus 30, because it's minus 30, so I'm going to add the 30. 12x plus x is 13x. 9 plus 30 is 39. And then x is 39 divided by 13, which is 3. X equals 3. Okay, question 8. On the grid, enlarge the shape, the shaded shape, with scale factor 1/2 and center 1, 2. Okay, once you know how to do these, guys, they're not that bad. Everyone can do this question, and I mean that. So 1, 2. I go to the center and I draw a line to the corner. Now, if the scale factor is a half, I'm going to be halving this line, the length of this line. So half of this line is here. This is half. Look, I'm going along 3 and up 4, along 3 and up 4. It's halfway, but count them properly, right? So this would be 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8. So if it's 6 along and 8 up, I need to go 3 along and 4 up to go halfway. So put a little point there. Then I do it again. Again, guys, use a ruler, obviously. I'm going to go to this guy and I'm going to go halfway. So from 1 to 15, halfway would be 8. And from 2 to 10, halfway would be 6. Is that right? Yes. So 8, 6 here. Okay, keep going. We do it to all the corners, guys. Now, even though you might think you can figure out how to do the rest of this now, we're still going to do it. So this guy is, again, 8, and halfway between 2 and 4 is 3. So it's just half of that line, however you want to do it, however you want to figure out how to get halfway on that line. But it should work out very nicely on a point. And then finally, this corner here, halfway is this. Now once I draw the points, it's very easy because I just need to connect them like this. So that, I don't think, is that hard, although many people will get it wrong for sure, because they don't draw the straight lines carefully and they don't find the midpoint carefully enough. Okay, that's question 8. Yes, I'm just checking if I'm right, and I am. Okay, question 9. Right angle triangle. Calculate the length of PQ. Give your answer to 3 significant figures, right? So we are looking for this side. We can call it X if we want. I'm going to call it X. So it's SOHCAHTOA. I'm going to write SOHCAHTOA. We have the adjacent. Tick for adjacent, or tick for A. And we want the hypotenuse. Tick for the hypotenuse. Which has the 2 ticks? Ka. So I'm going to be using cos. So cos 63 is equal to adjacent 24.3 over hypotenuse x. Okay, I have an x underneath the line that I don't particularly like, so I'll multiply across by x. So I get x cos 63 equals 24.3. And then to get x on its own, I divide. So I have 24.3 divided by cos 63. And this gives me 24.3 over cos 63 is 53.525. 53.525, and he wants it to 3 significant figures, so 53.5, that would be 3 significant figures. 53.5. Question 10. Okay, we need 3 inequalities that define the shaded region, right? Because this is going to be tricky. We have 3 lines. Okay, this is one. Actually, let me choose a different color. This is one line here. Now, what is that line? Well, it's x equals -1. That's that green line. I have this line. This is a pink line. What is it? Well, it's this. They've given it to us. Y equals 1/3 x minus 2. And then finally, I need have to use, well, I can use this blue. I have this line here. Now, I have the pink line. I now have the green line because it's x equals -1. That one's easy. What I don't have is this line here. I need to figure out what it is. You could use equation of the line and figure it out that way using the formula y equals mx plus c. But if you can actually just see that the gradient for this line, the gradient is the scales are the same, so it's just 2 over 2. For every 2 along I go up 2. So the gradient is -1. -2 over 2 is -1. Or look, if you want to think of it as 4 over 4 is 1, but it's going down, it's negative. So the gradient is -1. And the y-intercept, the c, is 4. So the line is y equals -1x or -x plus 4. That's what the equation of this line is. Okay, so now we have 3 equations. Okay, what inequalities will we use? Right, I'm going to write this here again, guys. This is x equals -1. So the easy one, the easiest one to do is to write that y is greater, sorry, x, what am I doing? This one, x is greater or equal to -1. So I assume they would accept, guys, that they would accept if you put greater than, but usually if it's just greater than, as in without the equals, if it was just that, this would be a dotted line. But because it's a solid line, we put greater or equal to. So x is greater or equal to -1. Why did I choose greater or equal to -1? Because it's to the right of this line. So that one's usually easy to do, and the horizontal ones are easy because it's either up or above. Greater than is above, less than is below. For the vertical line, greater than is to the right, less than is to the left. Okay, the second line that we already have is this one. Now, because it's actually given as y equals mx plus c, I can go straight to y has to be greater or equal to 1/3 x minus 2. Now, I always say just pick a point that is in the shaded region and check if it works. If 0, 0 is there, that's an easy one to do. If you put in 0 here, you get 0 is greater or equal to 0 minus 2. Is that true? Yes, it is. 0 is greater or equal to -2. It's greater than -2. So it works. So that is correct. And then finally, I'm going to use this line. Again, it's in the form y equals mx plus c, and the shaded region is below it. So I'm just going to do y is less than or equal to -x plus 4. Is that correct? Well, again, sub in 0, 0 and see does it work. You can sub in any point that's in here, but might as well choose the easiest one. Is 0 less than or equal to 0 plus 4? Yes, it is. 0 is less than or equal to 4. So that inequality is satisfied, hence that is the correct inequality. So these are the 3 inequalities. These questions are always difficult, guys, because you have to first get the line, find the equations of the line, and then decide which direction to put the arrow with. There you go. That is question 10. And obviously you can write them. You can write them there. There we go. Perfect. Question 11. Max invests $6,000 in a savings account for 3 years. It's a compound interest rate of 1.5% for the first 2 years. The compound interest rate changes for the 3rd year. At the end of the 3rd year, there is a total of $6,311.16 in the account. Work out the compound interest for the 3rd year. Okay, that's a bit tricky, guys. In fact, I haven't seen a question quite like this in the papers that I've done videos for yet. But we can do it. So the formula for compound interest is 6,000 times the 1 plus the interest rate. So 1.015, because you got to do 1 plus 0.015. 1.5% is 0.015, not 0.15. Just be careful. So it's that to the power of 2. And then times something else. And so that was the first 2 years. So that's why I did to the power of 2. And then we times it by another thing, another number, like 1 point something. I don't know what this is yet. Let's call it x. That's what we usually call when we don't know what it is. Let's be super careful, guys, if you're using a times sign here. That's why I put it in brackets. So this times x, and we know that this equals 6311.16. Okay, if that's true, then we can find this out quite easily by just dividing by this. I can say x is equal to 6311.16 divided by 6,000 times 1.015. Let's see what this is. So 6311.16 divided by, so I'm going to use this, divided by 6,000 times 1.015, and I get 1.036. Now hang on, guys, I realize I've made a mistake, a big mistake. I should have divided by this squared because of this. Look, I forgot the square. So let's actually do that again. But here I'm going to put squared like that. Press enter, and I get 1.021,000. So 1.021, and he wants it to 1 decimal place. So that's what we multiply by. Therefore, what's the interest rate? Well, the interest rate is then, and guys, maybe I will put in those zeros just to be clear. 0, 0, 0, and then 267. If this is what we multiply by, what's the interest rate? Well, the interest rate is 2.1. It's this bit, because remember, if it was 5%, we multiply by 1.05. If it's 8%, we multiply by 1.08. So if we have multiplied by 1.021, the interest rate is 2.1%. So, and he does want 1 decimal place, so the interest rate is 2.1. Okay, not a straightforward compound interest question. Question 12. A total of 80 men and women took part in a race. The cumulative frequency graph tells us information about the times. Okay, fine, that's our cumulative frequency graph. Use the graph to find an estimate for the interquartile range, right? Interquartile range, guys, there's 80 people. I'm going to go to the quartiles, so the quarter. Quarter of 80 is 60. So I go along, then I go down. These are nicely in ones, so that would be 35, 6, 7, 8. That's 38. That's Q1. Q3 is, I go to 60, because it's 3/4 of 80. 60, go down. Use a ruler, guys, obviously, 55, 56. So the interquartile range is going to be 56 minus 38. 56 minus 38 is 18. So the interquartile range is 18 minutes. Okay, 60% of the men took 50 minutes or less for the race. No women took 50 minutes or less for the race. Work out an estimate for the number of men who took part in the race. Okay, this, guys, I think is going to be tricky. So it's worth 3 marks. 60% of the men took 50 minutes or less. Okay, let's go to the 50 minutes mark. 50 minutes. Okay, I'm going to draw a straight line from 50 minutes straight up, and I get 42. Okay, so that means 42 people took 50 minutes or less. So 42 people took 50 mins or less. But it tells us that no women took 50 minutes or less. So these are all men. So 60% is equal to, so 60% of the men, 60% is equal to 42. So how do I find 100%, which is the total which I want? Is I can do 1%, or I can do 10%, or however you want to do it. We are going to divide by 60 and multiply by 100, or divide by 6 and multiply by 10. But I like to do, guys, 1% is 42 divided by 60, and then 100% is 42 divided by 60 multiplied by 100, and this gives us 42 divided by 60 multiplied by 100, 70 exactly. Okay, good. That is 70 men took part in the race. Okay, question 13. The cube is placed on a table. This is a solid cube, so that the whole of one face is in contact with the table. The cube exerts a force of 56 newtons. So we have the force. The pressure on the table is 0.14 newtons. We have the pressure. Work out the volume of the cube. Okay, so they've kindly given us the formula. So pressure is force over area. We have the pressure. It's 0.14. And that equals force, which we have, 56, over area. Let's call it A. I don't have A. I have now A in the denominator, which I don't want, so I multiply across to get it in the numerator. 0.14A equals 56. Then I divide by the 0.14. So this is 56 divided by 0.14. 56 divided by 0.14 is 400. Exactly right. So the area is 400 centimeters squared. But that's not what we're asked to find. We're asked to find the volume. So if the area is 400, what is W? Well, think about it. W times W, that's the area, because the area is the area of the base, because this has been put on the ground. So the area that's touching the table is actually W times W. So W times W, or W squared, equals 400, which means W is the square root of 400, which is 20. Use your calculator if you want. And then the volume, if you have a cube and you know the width or the length, which is the height, and they're all the same, it's just going to be 20 cubed. So the volume is 20 times 20 times 20, which is 8,000 centimeters cubed. So it's 8,000 centimeters cubed. Okay, that is question 13. Question 14. So we have a parallelogram, EFGH. They give us this length, and this angle, and they say, part A, work out the area of the parallelogram. Okay, so guys, the area of a parallelogram is, the formula is base times height. So if I had this height, I could just multiply by 4.7 because 14.7 sorry, is the base. And I could find this fairly easily, guys, by using cos, because I know if this full angle is 106, this is a right angle, this has to be 16 degrees, and I could figure out h using that method. However, there's an easier way to do it. Well, I think it's an easier way to do it because you just have one formula to use. If I draw this line straight across here, if I can get the area of this triangle, I can just double it, because this triangle and this triangle are the exact same thing, because it's a parallelogram. I've just kind of halved it. So I can get the area of this triangle, because the area of a triangle from the formula sheet is a half AB sine C, or a half this side times sine of this. So it's a half 9.3. Now, hang on, I should say, sorry guys, area of the triangle is equal to, or even area of EFG is equal to a half 9.3 14.7 times sine of 106 degrees. Calculator, a half is 0.5 times 9.3 times 14.7 times sine 106, 65.707. 65.707. Therefore, area of well, let's just call it A. A is equal to 65.707 times 2, which is times 2, 131.414. Let's write that here, 131.414. He says 3 significant figures there, so let's call this 131. Okay, then part B, he says work out the length of the diagonal EG, right? So that's nice because I've already drawn this. Let's call it X. Give your answer to 3 significant figures, right? So guys, this is a very typical, clear cosine rule question. You've two sides and the angle between them, and you're trying to find the length of the other side. It's cosine rule. So the cosine rule is x squared equals, so it'll be this squared plus this squared minus 2 times this times this. Let's just write it here. X squared is 9.3 squared plus 14.7 squared minus 2 times this times cos of 106 degrees. X squared is equal to, I'm going to do this bit on the calculator first, 9.3 squared plus 14.7 squared minus 2 times 9.3 times 14.7 times cos 106. Cos 106 gives me 377.944, 377.944 or 945 rounded, and then I need to get x, so I need the square root of that. So I do square root of the answer is 19.44 equals x equals 19.44. Again, 3 significant figures, 19.4. Question 15. The diagram shows a cuboid of volume V centimeters cubed. Show that V is equal to this. Okay, so I think, guys, we can all get the first step here. The volume of a cuboid, hopefully, we know, is equal to base times width times height. This times this times this. So that's 2x plus 5 times 3 minus x times x plus 1. So this question, while it's not easy, is somewhat familiar now because it's just multiplying on 3 brackets. Now, multiplying on 3 brackets, I'm not going to say it's easy because it's always a pain and it's easy to make mistakes, but it's something that definitely you can practice beforehand a lot and be confident going into the exam. So how do we do it? Well, you do 2 first. So I'm going to multiply this by this. So actually I'll do them at the side here. I'll do 2x plus 5 times 3 minus x. It doesn't matter which 2 you choose. I'm just choosing those 2 because they're the first 2. You could choose the second 2, or you could even choose the first and the third. So this is, we have to do first times the first, first times the second, second times the first, second times the second. And I get 2x times 3 is 6x, 2x times minus x is minus 2x squared. 5 times 3 is plus 15, 5 times minus x is minus 5x. Simplify this, 6x minus 5x is just x, minus 2x squared plus 15. I'll leave it like that, that's fine. Then I need to multiply this, x minus 2x squared plus 15, what I just got, because that is the first 2 here, by the third one, which is x plus 1. Now when multiplying an expression with 3 terms by an expression with 2 terms, or it's the same for whatever, if you 10 terms, and 10 terms, you have to multiply all the terms by each other. So you have to do the first times the first, x squared, the first times the second, plus x, then the second times the first, minus 2x squared, the second times the second, sorry, that was wrong, 2x cubed, the second times the second, minus 2x squared, the third times the first, plus 15x, the third times the second, plus 15. And then I'm going to just simplify this. I'm going to put the 15 first, just because he's put the 15 first. My x plus 15x gives me plus 16x. 16x. The x squared minus 2x squared is minus x squared. And then finally, there's just this minus 2x cubed. And that's it. That's what he wanted. Okay, part B, it says there is a value of x for which the volume is a maximum. Here. Find this value of x, show you're working clearly, and give your answer correct to 3 significant figures. Okay, this is going to be tricky, guys. So first and foremost, I'm going to go back to this. I'm going to copy it just so I have it here. This is my volume. Now guys, the reason I've highlighted maximum is because that maximum tells me that I am going to use calculus and differentiation. I'm going to differentiate this to find the maximum, because the maximum occurs when the derivative equals 0. So I'm going to go dv dx. I'm going to differentiate volume with respect to x. Differentiate. The 15 goes to 0. The 16x goes to 16. 2 minus x squared becomes minus 2x. I multiply by the power, subtract 1 from the power, and here I multiply by the power and subtract 1 from the power. This is the derivative. Then it's saying show you're working clearly, so I'm going to say at max dv dx equals 0. So I'm going to equate this 16 minus 2x minus 6x squared, equate it to 0. I'm going to multiply across by -1 just so I have a positive 6x squared. I can do this, multiply or change the signs of everything because I'm multiplying both sides by -1. -1 times 0 is 0. I'm going to divide by 2 because I can. 3x squared plus x minus 8 equals 0. And now it's a little bit easier. So does this factorize? Let's have a look. I can do 3x and x. I can do 4 and 2, that won't work. 1 and 8, that won't work. So it actually won't factorize. But and because he's actually said give your answer correct to 3 significant figures, that tells me that this is quite possibly, well, it tells me I'm going to have to use the formula. So the formula is x equals minus b plus or minus, this is in the formula booklet, guys, plus or minus the square root of b squared minus 4ac all over 2a. Now, by the way, guys, this would have worked if you left it in this form, and it would also work if you left it in this form, but this is going to be the easier one. Now, I'm just going to write down here, guys, a, always do this, a equals 3, b equals 1, c equals -8. And then when I sub into here, which I'm going to do over here, I'll do x equals minus b minus 1 plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 3, times c, -8, all over 2a, which is 2 times 3. This is equal to minus 1 plus or minus the square root of, the minus times minus is plus, so it's going to be 1 plus, use your calculator here, guys, if you want. Actually, I'm going to use my calculator. So it's 1 plus 4 times 3 times 8, which is 97. So it's minus 1 plus or minus the square root of 97 all over 6. Now note, guys, x, let's have a look here. Well, this is particularly not nice because x has to be, well, x has to be a value that when you sub into each of these, it's positive. So let's actually find out what the two values of x are. So I'm going to do -1 plus root 97 over 6, which is 1.4748. So x equals 1.4748, and I then need to do this minus, which gives me minus 1.808, or x equals minus 1.808. Now, just be super careful, guys. Often I'd say x has to be positive because it's a length, but x isn't actually a length. X plus 1 is a length, and 3 minus x is a length, and 2x plus 5 is a length. So you have to be careful. For example, if x was positive 5, this wouldn't work because you'd have 3 minus 5, which is -2, and you can't have a length of -2. Now, what happens is the 1.47 works because if I sub in 1.47 into all of these, it's a positive number. But if I sub in -1.808, I think it was, if I sub that in here, this is actually a negative number, so that's no good. So x has to be the 1.47. So the answer is, and it's 3 significant figures, x equals 1.47. Okay, tricky question. Question 16. Okay, this, guys, is definitely what I call a familiar question. I feel I've just done loads of these in my previous videos. P is this, A is this, C is this, D is this. We need an upper bound for P. Show you're working clearly correct to 2 decimal places. Right, so if you've seen my previous examples, guys, I do this. I draw a number line for A. I draw a number line for C, and I draw a number line for D. So this is A, C, and D. Now, we want to make P big. Okay, P big. So, to make P big, we need to make A big, because A is in the numerator. So to make this big, obviously we need a big numerator. But if we want a big numerator and we're subtracting c, you actually want to make c small, because you want to subtract a small number. And then, because, and this is why this is a tricky question, guys, to make p big, we want the denominator to be small. So d has to be small. So that's the first step. Then we go to each of these. So a is 58.4. So here, 58.4. Now the next number up is 58.5 if we're dealing with 3 significant figures. The next number down is 58.3. I'll do this for each of these now, guys. C is 20 to 2 significant figures. So the next number up is 21. The next number down is 19. And this is 2 significant figures, so 3.6, 3.7, and 3.5. Now we want, sorry guys, I'll put that more here. We want an upper bound, so we want to make a big. So to make a big, we go halfway between this, and we get 58.45. To make c small, we're going to go here, halfway between 19 and 20, which is 19.5. And to make d small, we're going to go here, which is 3.55. Now I've got these 3 values, all I do is sub them in. So I say p is equal to 2 times a, which is 58.45, that's this number, minus c, which is my 19.5, divided by d, which is 3.55. Sub all that into the calculator, and I get 2 times 58.45 minus 19.5 over 3.55, and that gives me 27.4366. 27.4366. Look at this, 2 decimal places, 27.44. 27.44. Okay, that's question 16. Question 17. Show that this squared equals this, and show each stage of your working. Okay, so guys, don't use this. This is the answer. We're going to get to that. We're going to square this, which is 6 plus 2 root 12 times 6 plus 2 root 12. So we're going to multiply this by itself, and we're going to multiply it out the long way. This times this, this times this, this times this, this times this. 6 times 6 is 36. 6 times 2 root 12 is plus 12 root 12, because you just do 6 times 2. Similarly, 2 root 12 times 6 is plus 12 root 12, because 2 times 6 is 12. And then finally, 2 root 12 times 2 root 12, guys, you can do this. I've done it here in your calculator. 2 root 12 squared is 48. Or you might know that 2 times 2 is 4, root 12 times root 12 is 12, 4 times 12 is 48. Either way, it's 48. And then I'll add 36 plus 48 is 84. And 12 root 12 plus 12 root 12 is 24 root 12. Like 12x plus 12x is 24x. Okay, now he wants it in this form. He wants 7 plus 4 root 3. So I want to get that root 3 out here. So this is 12. So first, let's just change the 12 into root 4 times root 3. I can do that because 4 times 3 is 12. Okay, then I know root 4 is 2. And 24 times 2 is 48. So it's 48 root 3. And now all I have to do is take out the 12. He helps me because it's there, but it's a common factor of 84 and 48. So take out the 12. What's left here? Well, 7, because 7 times 12 is 84. And what's left here? 4, because 12 times 4 is 48. And obviously the root 3. And there we go. That is it shown. Okay, part B. Simplify this. Okay, so obviously lots of different rules here that I need to be careful about. The first rule, guys, is when I have a negative power, I get the reciprocal and make it a positive power, or in less formally, flip it upside down. So I'll have t to the 15 over 27a to the 12. So I've just flipped the fraction upside down, and then the power is positive, so it's this to the power of 2/3. Okay, now I'll separately do, over here I'll do t to the 15 to the power of 2/3, because when you have a fraction to a power, you have to do the numerator to the power and the denominator to the power. T to the 15 to the power of 2/3, I multiply the powers. 15 times 2/3 is 10. Use your calculator if you want. And then 27 a12 to the power of 2/3. Well, this one, you could almost split this again, but 27 to the power of 2/3 is 9. You can do that with your calculator, guys. Or, so 27 to the power of 2/3 is 9. If you know how to do it without your calculator, even better. It's the cubed root, which is 3, squared, which is 9. So that's 9. And then a to the 12 to the power of 2/3, like this one, we multiply. 12 times 2/3 is 8. Use your calculator if you need to. Therefore, this thing equals t to the 10 over 9a to the 8. T to the 10 over 9a to the 8. Okay, t to the 10, 9a to the power of 8. Okay, question 18. There are 16 sweets in a bowl. 4 of the sweets are blackcurrant, 5 are lemon, and 7 are orange. Anna, Ravi, and Sam each take a sweet from the bowl. Work out the probability that 5 lemon sweets are still in the bowl. Okay, so that basically means, guys, that Anna takes a sweet and it's not lemon. Then Ravi takes a sweet and it's not lemon. And Sam takes a sweet. Sam takes a sweet and it's not lemon. Now, this question, I think they've actually tried to make it more difficult than it needs to be by saying blackcurrant and orange. All we need to know is that there are 5 lemon and there are 11 not lemon. And 5 plus 11 is 16. So there's 16 sweets in total. So if I actually have my, let's say I have my bowl of sweets. Let's try and draw a bowl. That's definitely not a bowl. That's also not a bowl. That'll do. So here we have a bowl, and in the bowl we have 11 not yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 not yellows, or not lemons, and I've got 1, 2, 3, 4, 5 lemons. Anna is going to pick a sweet and we want it to be not lemon. What's the probability? So the probability of, well, 5 lemons left. So 5 lemons left is the same as them all picking not a lemon. So Anna to pick not a lemon, that would be 11 out of 16, because there's 11 sweets that are not lemon and 16 in total. Now, if she takes a sweet, this is why I like to draw these pictures, guys. If she takes a sweet out that's not lemon, now for Ravi, there are only 10 sweets that are not lemon and 15 in total. So it's 10 out of 15. Similarly, we're going to take out a sweet because Ravi has eaten that. How many are left? 9 not lemons. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a total of 14. Count them. Then all I need to do is multiply these numbers out. So I'm just going to do 11 times 10 times 9. I can multiply fractions like this. 16 times 15 times 14. And I get 33 over 112. 33 over 112. Now the mark scheme gives me 990 over 3360. I just want to check that that's the same. 990 over 3360. Yeah, it's the same answer. I think the mark scheme makes it more complicated than it is too. So in my opinion, that's the easiest way to do it. Okay, that's obviously wrong, guys. There we go. Okay, question 19. The diagram shows a cuboid, A, B, C, D, E, F, G, H. It gives us the length. It says work out the size of the angle between AH and the plane EFGH. So this is the plane, the bottom side of the cuboid, if you like. Now the angle he wants is the angle between AH, which is this line, and the bottom. So I need to go along the bottom of this of the cuboid back to directly underneath where I started, join this up here, make myself a nice triangle. But the angle he wants is this. That is the angle between the line and the plane. Let's call it theta. Okay, now I'm actually going to, at the side here, draw that triangle. And note, it is a right angle triangle, even though it doesn't look like it. It is a right angle triangle because here, this is a right angle triangle. Because think about it, in 3 dimensions, this is the ground, this is the bottom of the cuboid, and this is a line going straight up to the top of the cuboid. This is a right angle. So here I have a right angle, and this is AFH. Now, to get the angle, I can use SOHCAHTOA if I had 2 sides, but I don't have 2 sides. But I actually have one side. I have this side here, because that's 6, because the height is 6. So this is 6. But I don't have another side. But I can find one. I can find this side here, this x, which is this x. And the way I can find it is using this triangle at the bottom. So again, I'm going to draw a different triangle. I'm going to use a different color. And I'm going to draw a different triangle down here. So this is the triangle EFH. Now note, it is a right angle here at E. Why? Well, again, think about a cuboid on the ground. This would be a right angle here. So this is actually a right angle on the flat surface. So hence when I draw it, it's a right angle here. Now, let me draw that F again, guys. That's annoying me. This is F. Okay, so what I'm trying to find is this X value here. What I have is this side here. It's 9. This EH is 9. And this EF is 5 because it's the same as this. So this is 5. Now I can find this x using Pythagoras' theorem. So I can say x squared equals 5 squared plus 9 squared. X squared equals 25 plus 81. X squared equals, use your calculator if you need to guys, 106. X is equal to the square root of 106. That's Pythagoras' theorem. You can write this as a decimal if you want, but I prefer to just keep it as root. So just be careful guys, it's this x here. This x is root 106. So note what's happened guys. The x on the hypotenuse of this triangle is the x on the adjacent of this triangle. So now I have this length, it's root 106. I'm actually just gonna, let's get rid of the x, put 106. Now I can use SOHCAHTOA. So opposite, adjacent, it's tan. So tan of theta is opposite over adjacent. Theta is the inverse tan of this. The tan minus 1 of 6, 106, which is equal to inverse tan 6 over root 106, close brackets, 30.232. 30.232. He says 3 significant figures, that is 232. 232, that is 30.2. Okay. The curve C has this equation here. A is greater than 4, which I believe is important. Using this axis, sketch the graph of C. On your sketch, show in terms of A, the coordinates of intersection of the axes and the coordinates of the turning point. Okay, so guys, this is a difficult question. So let's start with the coordinates of intersection. So a graph crosses, let's start with the y-axis. It crosses the y-axis when x is 0. When x equals 0. Crosses the y-axis when x equals 0. So that means y is equal to 4 times 0 minus 1 squared, which is just minus 1 squared, minus a, which is 4 minus 1 squared is 1, 4 minus a. So it's going to cross the y-axis at 4 minus a. Now note guys, a is bigger than 4, so 4 minus a is less than 0, so it's going to be underneath the x-axis. It crosses the x-axis when y equals to 0. Now that's true for any graph. Crosses the x-axis when y is 0, the y-axis when x is 0. So I'm going to say 4 times, actually guys, I'll do this over here because I need space. I'm going to say 4 times x minus 1 squared minus a equals 0, because this equals y equals 0 because y is 0. Then I'm going to solve for a. So I'm going to, solve for x. So I'm going to add a to both sides. So I have a here plus a. Divide by 4. So I have x minus 1 squared equals a over 4. Get the square root. X minus 1 equals the square root of a over 4. And then x equals, add 1. So it's 1 plus the square root of a over 4. But it's 1 plus or minus the square root of a over 4. Hence, you're going to have the two roots. And then finally, guys, I'm going to simplify this into 1 plus or minus the square root of a over 2, just because the square root of 4 is 2, so I can take it out of the root, and there we have it. So these are the two these are the two roots where it crosses the x-axis. Now, it's important x is bigger than 4 because that means one of these is going to be if a is bigger than 4, it's going to be 1 plus a number that's bigger than 1, and it's going to be 1 minus a number that's going to be bigger than 1. Now, before I plot them, let's get the turning point. So the turning point, if you're familiar with or you understand this completed square form, I actually have the turning point. The turning point is 1 minus a. When it's in this form, the turning point is this, but if that's minus, you put a plus, and if that's plus, you put a minus. This one is just whatever it is. If it's minus a, you put minus a. I won't go into too much detail about why that's the case, but it is, and you should learn why when you do the completed square form. Anyway, that's the turning point, 1 minus a. So now I actually have all the information I need. So the turning point is at 1 minus a. So I'm going to put it down here. It's at, let's say, 1 minus a is there, because a, remember, is bigger than 4. So it's 1, that's 1 minus a. It crosses the y-axis at 4 minus a. So 4 minus a would be minus a plus 4, so somewhere up here. Now remember, a is greater than 4, so it is going to be a negative number. So it's going to be somewhere between here and here. It doesn't really matter where. Let's just put it there. So this is 4 minus a. Then it's crossing the x-axis at 1 plus root a over 2. Let's put it, and 1 minus. Okay, so let's just go with, I might just move this down a little bit, guys. So there, just so I have enough space. But so long as all these are drawn in the right quadrants, it's not a big problem. So this is, let's go there. This is going to be 1 minus root a over 2. And then this would be 1 plus root a over 2. So these are my two, sorry guys, it's 1 minus root a, it's 1 minus root a over 2. That's the x coordinate, comma 0, I should have said. And then this one here is 1 plus root a over 2, comma 0. Then I have to obviously join these together, guys. So does he want me to draw it from any particular point? No. So I'm just going to go down through this coordinate, turn at this coordinate here, and then back up. Now guys, obviously my drawing is not great, but I might actually do it again. You can obviously do it better. Through there, turn, and through there. That's just pretty much as bad as the previous one, but yeah, try and draw it a little bit better. But what's important is that you have the where it crosses the x-axis, where it crosses the y-axis, and where it turns, because that's what he asked for. Okay. Question 21. The function h is such that h of x equals f g of x. Express the inverse function h minus 1 of x. Okay, so first let's get h of x. So h of x is f g of x. So we're going to put g into f. So instead of x, I'm going to put x plus 3. So instead of x squared, it's x plus 3 squared. Instead of 2x, it's 2 times x plus 3. expand all of this out. Becomes x squared plus 6x plus 6. Guys, do that the long way if you need to. X plus 3 times x plus 3 gives you this. Minus 2x minus 6, which gives me x squared. Actually, sorry guys, that's not 6, that's 9. That's a mistake. I should have done it the long way. 3 times 3 is 9. Minus 2x minus 6. And then this is x squared minus 2x, plus 6x minus 2x is minus 4x. Oh, sorry, plus 4x. I'm not on it today, guys. Plus 4x, and then 9 minus 3 is plus 3. That's h of x. Now he wants the inverse function. To get the inverse function, guys, and that is why this is a question 21. This is a hard question. To get the inverse function of a quadratic, you have to complete the square. How do I complete the square? Well, I'll do this fairly quickly, guys, but you might have to go back and learn it. We do x plus 2. You half this, gives half the 4 to give me 2, and square it, but we have to subtract 2 squared, and then I add the 3. Hence, I have x plus 2 squared minus 1. That is h of x in completed square form. Then to get the inverse function, I let y equal x plus 2 squared minus 1. I then swap x and y. X equals y plus 2 squared minus 1. And I solve for y. So I then say y plus 2 squared equals x plus 1. I add the 1 over here. Get the square root. The square root of x plus 1 equals y plus 2. And y is equal to minus 2, because I'm going to subtract this 2, minus 2 plus the square root of x plus 1. So the inverse function is minus 2 plus square root x plus 1. He says here x has to be bigger or equal to negative 2 for the function, therefore the range has to be bigger or equal to negative 2. So it has to be plus, it can't be negative. It has to be minus 2 plus this, not minus this. Okay, that is question 21. Question 22. Triangle HJK is isosceles with HJ equaling HK. Okay, so let's draw this triangle. HJ, and this equals HK. Okay, so this is, hang on, let me draw that again. It wasn't perfect enough. Okay, that's better. This is H, this is HJ, and this is HK. He then says that JK is root 80. So this length here is root 80. H is the point with the coordinates minus 4, 1. These coordinates are minus 4, 1. J is J15, and K is 6K. M is the midpoint of JK, so M is here. I'll just move that root 180 to note it's nothing to do with that M. Okay, that's in the middle. So the root 80 is the full thing, guys, you know that from J to K. The gradient of HM is 2. Okay, so the gradient of this line here, okay, hang on. This line here is 2. This M equals 2. Now that means the gradient of this line, this M is equal to -1/2. How do I know that? Well, because it's an isosceles triangle, they're perpendicular, because look at it, this has to be perpendicular, it's coming straight down. Okay, the question says find the value of j and the value of k. So right, this is a hard question, guys, I'm not gonna lie. What I'm gonna do, so I have two unknowns, j and k. The fact that I have two unknowns is the hint I need to deduce that I probably need to make two equations and solve them simultaneously. So the two equations I can use is, let's use this bit of information. I know the gradient is -1/2. So the gradient of jk is, from my formula, m equals y2 minus y1 over x2 minus x1. This is y2 is k, y1 is 15, x2 is 6, x1 is j. This has to equal -1/2. Okay, cross multiply. 2 times k minus 15 equals -1 times 6 minus j. 2k minus 30 equals -6 plus j. Okay, let's just simplify it a bit. 2k minus 24 is equal to j. I just added the 6 to this side. Okay, there's my first equation. My next equation, oops, I didn't want to do that. My next equation is I'm going to use the distance, because he's given me the distance. The distance is √80. So between these two points, the distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. I forget, guys, if we're given that in the formula, but I don't think we are. Let's have a quick check. No, we are not given that formula, the distance formula, the midpoint formula, the gradient of a line formula. Therefore, you need to know it. Okay, you need to know that distance formula. It just comes from Pythagoras' theorem, if that helps. Okay, the distance is √80. We're told that. So √80 is equal to the square root of x1 minus x2, that's j minus 6 squared, plus 15 minus k squared. Square both sides. 80 equals j minus 6 squared plus 15 minus k squared. Okay, now I have two equations, this equation and this equation. It's a simultaneous equations where one of them is non-linear. So what I'm going to do is substitute this into this for j. Okay, so let me try and explain what I'm going to do. I'm going to put this is j. So instead of j, I'm going to put that. Okay. I might even just write solve simultaneously. Okay, again, guys, warning, I know this is very difficult. Okay, 80, and I might actually put the equals on the right, if we're okay with that. So instead of j, I put 2k, actually let's just put the 80. 80 equals, instead of j, 2k minus 24. There we go. I still need the minus 6, and I still need to square it. Plus 15 minus k squared. This is equal to 2k minus 30 squared plus 15 minus k squared. I'm going to have to square out both brackets. I'm going to do it the quick way, guys. If you don't, or if you want, well, you should do it this way. Multiply it out properly like this. 2k minus 30 times 2k minus 30, and 15 minus k times 15 minus k. I'm going to do it quickly, and it's 4k squared minus 120k plus 900 plus 225 minus 30k plus k squared. As I say, guys, there is a quick way to do this, which you're more than welcome to learn, but I'm not going to show you right now. And even if you're really comfortable with that other way, I still recommend in an exam do it out the long way. This times this, this times this, this times this, this times this. Anyway, you should get this. Then simplify. 4k squared plus k squared is 5k squared. Minus 120k minus 30k is minus 150k. 900 plus 225 is plus 1125. Subtract the 80, and I get 5k squared minus 150k plus this minus 80 is 1045. Then divide across by 5 because it's easier. 0 equals k squared minus this divided by 5 is 30k. This divided by 5, use your calculator if you want, it's 209. Okay, then factorize this. Now guys, I'll be the first to admit that is not that easy to factorize. So what I'm going to do is use my calculator to help me. I put in a polynomial, unknowns, number of unknowns is 2. No, that's not what I wanted to do. This polynomial, degree 2, then I put 1, negative 30, and 209. Press enter and I get 19 and 11. Okay, thank you. That means the factors are k minus 19 and k minus 11, because 11 times 19 is 209. This equals 0. Therefore, the solution is k equals 19 or k equals 11, which my calculator told me. But I have j equals 2k minus 24. J equals 2k minus 24. That was given in the well, that's the bit I highlighted there. That's the substitution I used. So I then say j, well, let's do for k equals 19. J equals 2 times 19 minus 24. 2 times 19 is 38 minus 24 is 14. And for k equals 11, for k equals 11, j is equal to 2 times 11 minus 24, which is negative 2. Okay, so now I've got two pairs of solutions. I have j equals 14 and k equals 19, and here I have j equals negative 2 and k equals 11. Now we just want to make sure or check, go back to the question, and they've obviously given us two pages here to work with because it's such a long question. Now just be careful, like I was a bit surprised to get 2 answers. well, I wasn't considering I had a quadratic, but I just want to know which is the right answer, because I can't really have two different answers here when we're talking about points. But it says j is less than 0. So if j is less than 0, it can't be this one, because j has to be -2. The j has to be negative, therefore -2 and 11. So just be careful when, I mean, under normal circumstances, you can have two different solutions. In fact, normally when we solve simultaneous equations with a nonlinear equation, we do get two sets of solutions. But just be careful, read the question and note, is there some condition where one of the solutions doesn't count? Because you'd lose 1 mark at the end if you didn't put this, and you might even say no, not valid as j is less than 0. There we go. Okay, obviously super hard question, guys, but that's the paper done, and I'll see you for the next paper.